thank you. Welcome to GeeCON, and thanks for joining my talk. It's all about database-less high-performance persistence with EclipseStore, building applications that are 1000x faster and saving 98% cloud costs. My name is Markus Kett. I'm CEO and co-founder of MicroStream. And together with my team, we work on Java for almost 20 years now. So a little bit about my history and why I talk about persistence stuff. So we work on open source projects for more than 10 years now, and we've started various open source projects like Eclipse, RapidClipse, which is an Eclipse-based Java IDE. So the idea was building a Java IDE that works similar to Visual Basic, so for building applications in Java easily. This works really great because we had nice GUI builders. The problem here was database programming was mostly too complicated for our users. So this was the reason why we worked on improving the JBoss Hibernate tools. We wrote some extensions. We tried to make it more simple and convenient, and also worked on cache layers. But finally, it doesn't work well. So because it was still too slow, it was effortful and complicated. So this was the reason why we started working on a completely different approach. Then we started the MicroStream open source project. Then we founded a company around for the project to finance the project, and now we donated everything to the Eclipse Foundation. Last year at GeeCON, we announced we want to run this as a Eclipse project, voila, now it's an Eclipse project. So last year in December, we joined the Eclipse Foundation and donated the code to the Eclipse Foundation. Now we have 2 Eclipse projects launched. So one is, so the MicroStream open source project is split into 2 Eclipse projects now. One is Eclipse Serializer. It's already launched as a final release last week. And we are still waiting for the final release of EclipseStore, what is now topic in this talk. And we also want to work on a new standard for the EclipseStore functional principle. So the framework is already well integrated with Helidon. So thanks to the Helidon team. They have integrated MicroStream almost 2 years ago. And we also have a beautiful integration with Micronaut, and more frameworks are using EclipseStore. All right. So who of you have ever heard about the MicroStream open source project already? Okay, some. I will explain a little bit about the functional principle, and tomorrow we have a talk, so Christian will explain how to get started coding. So more and more applications are dealing with more and more data, and so the modern applications, they produce and consume tons of data. And of course, AI, machine learning is super popular these days, and with AI, machine learning, the amount of data globally will explode. And there are 3 critical factors for all of these modern fancy applications: high performance, low data storage costs in the cloud, and simple implementation for a fast time to market to save money. This seems obvious, right? But for processing and storing data, we actually use systems, traditional database systems, and I would say, so is my personal opinion, in comparison to Java as a powerful programming language, databases are slow. They are built for specific use cases, They are very expensive in the cloud and lead to a high complexity. So the question is, are the databases, traditional databases, really suited for these modern applications? Make your own decision. So what's the problem actually with traditional databases? So here we can see an architecture overview. Simple Java application. We have a Java virtual machine. We have memory, our objects in memory, and we have an application or a microservice. Everything is great because we have a great programming language. Java is object-oriented, type-safe. It's fast in memory. We have the great JIT compiler that's super fast. As soon as we want to store data, we have challenges because then we obviously store data in a database, in a relational database. And relational databases are completely incompatible with the Java object model. It's not possible to store any kind of object graph seamlessly in a database. This is not possible. Why? It's because we have some impedance mismatches here. So the object models can be much more granular in comparison to a relational model. Subtypes are not supported by the relational model. You can browse through an object graph very easily because all objects are connected via the object IDs. This is not possible in the relational model. We need SQL, and so on. Data type differences. In Java, we have only some primitive types, right? And in databases, sometimes we have more than 30, 40, 50 data types. So how does this fit together? These challenges lead to increasing complexity. It's the same with NoSQL databases. So the NoSQL databases, they are different. They introduce new data structure or formats. So we have now the key value stores. We have document-based databases, so we using JSON, for instance. We have the graph databases for complex structures. And we had the object-oriented databases in the 1990s. We have now the vector databases for AI machine learning. So a lot of different database systems, and they are all incompatible with the Java object model as well. So we have same or similar challenges here as well. Of course, it's solved. So I mentioned we worked on improving the JBoss Hibernate tools. So with object relational mapping, we are able now to store objects in a relational database, of course. So we add a framework, or we use some data conversion. So if you use a JSON-based database, you need this JSON conversion. But we need this object relational mapping or this data conversion through every single read and write. And this leads to very expensive latencies. So you can read about this more in the internet. So there are a lot of great articles about this impedance mismatch. It's solved. I mean, so we have the object relational mapping frameworks. We have data conversion. It leads to expensive latencies. It almost doubles your query time. It slows down your application. So what we are doing is, in practice, okay, we can accelerate our application by using just a cache. Okay, you can add a cache. So now you can keep your result sets in the memory. Great, now you have access to memory. It's much faster. So who of you is building distributed applications? Okay, some. What's the challenge with distributed application and when you run a local cache? So if you have one application node and there is some changes in your data, you store the data, then the application node is in sync with your database. That's great. The problem is all the other nodes are not in sync with the database. That's not that good, so probably we have some issues here in data consistency. Well, we can solve this. So there's another cache strategy. Just put the cache in between your application and the database. So of course, we want to avoid a single point of failure in the cloud, so let's run a cache cluster. This is distributed cache. Who of you uses distributed caches like Redis? All right, so this is really common. So we can see the complexity is growing. And most people want to run small application nodes because memory is expensive, right? So keep your Java instances small, please. Yeah. But the problem is we run a distributed cache, and of course we need a lot of memory for running a cache. So otherwise it makes no sense. So actually we need a lot of memory. The question is, in which layer do we use this or need more memory? But we have to pay. And if the load goes up on the database, what can we do? Okay, we just run more database nodes to share the load, to have high availability. So we need more database nodes, and we use replication. So you can see we run 3 clusters. We need a lot of machines. We need a lot of CPU. CPU are expensive, so computing is expensive in the cloud. And sometimes this is not the end. Who of you uses a searching solution like Elasticsearch? All right. Why? Your database should be fast enough. So some organizations, or a lot of organizations, use searching servers on top of that to accelerate database applications. Then you have 4 clusters running. So, and it's just for, we wanted to store objects initially. There are other solutions on the market. We have the in-memory data grids. You can, yeah, so the difference actually is, so the in-memory data grids, they add some computing features on top of what the distributed caches provide. Then you have an in-memory data grid. You can, it's pretty much the same architecture, and you also could run an in-memory database. So an in-memory database, it sounds like it runs in memory, it runs in the same JVM process as your application, which means it should be fast, but keep in mind, the in-memory database is also a database server. It runs on its own remote machine, so we have wire in between. So this is the reason why this is not that fast as we would expect, because it's not in-memory performance. We have wire in between, we have separated, we have remote machines. So we have these challenges, but it's common, no worries. Then with microservices, we have new challenges. So with microservices, we split the monolithic application into hundreds or sometimes 1,000 isolated services run in their own container, and there are some rules with microservices. So one of these rules is, if you have a microservice that deals with data, should have its own database. So imagine we have a microservice that consumes sensor data. So which database system would you use? Probably time series database would be suited for such a service, right? If you have a service that is responsible for complex data structure, so probably you would use a graph database. But the graph database vendor, they would tell you, oh, this is really great for complex structure, but if you consume a sensor data, don't use us. Use a time series database. So sometimes you run an Oracle database, then you have a relational database. Probably you need have some unstructured data, then it might be a good choice to run a document-based database like MongoDB. So with microservices, you would run multiple different database systems because they are all limited in terms of the use case, the data structure, so they are built for specific use cases. And now if you want to build some machine learning algorithm, probably you would use a vector database. So many different database systems, increase your complexity, increase your effort of development, testing, deployment, and of course the costs in the cloud. And this is the reason why Java Enterprise applications are so expensive, or very often so expensive in the cloud. And managed databases in the cloud are very expensive. Why? It's because computing resources are expensive. Storage is not. An example, here we need 250 gigabyte PostgreSQL as a service at AWS. It depends on the machine. Let's assume we need a machine for CPU, 16 gigabyte memory, costs you around $3,000 per year. Okay, we want to share the load, high availability, so we need some more replicas. If you need more nodes, your price will double, will triple, will skyrocket. So if you need you want to run 6 nodes, it costs you $18,000 per year. There is a cheap solution existing already. The cloud vendors provide object storages. So binary data storage like AWS S3. The cool thing here is 250 gigabyte S3 cost only $70 a year. That's it. You don't have to care for replication, for uptime, for backups, data center replication. That's provided by the cloud vendor. So it's more than sometimes 98, sometimes more than 99% cheaper than a database as a service. And we don't talk about license fees, right? So this is not an enterprise database. With Oracle or Microsoft SQL Server, this is more expensive, even more. So, okay. So there is a cheap solution for data storage in the cloud. What about performance? Java is great. So we are at the Java conference. I have to say this, of course. We have a great JIT compiler, and the Java guys, so Brian Götz last week said, or 2 weeks ago said, yeah, with the JIT compiler performance, we can even outperform C programs. Oh, this is a great info. So we are faster than C because of our JIT compiler. So we have great performance. And we have a great data model. We have a great data structure because we have the Java object model. We can do everything. We are not limited as the databases are. So we can store some single values, we can deal with lists, simple lists for sensor data, but we can also create complex object structure like a graph database. And we can deal with vectors in Java. This is not a problem. And we have a great query language. We have the Java Streams API. With Java Streams API, we are able to search object graphs in memory in microseconds. So even if you have a terabyte data in memory and complex object structure with circular references, you can search your object graph in microseconds. What's the difference between a SQL query? When we talk about the performance of database, we talk about milliseconds, right? So milliseconds versus microseconds, this is 1,000x faster with Java Streams API, or it should. The only thing missing in Java is, unfortunately, there is no feature to store objects persistently on disk. Probably they have forgotten something, right? No programming language actually has a feature to store objects persistently on disk. So, obviously, we have databases for that. There is an interesting project, JDK project called Crack. They store the state of your JIT compiler on disk. They create a snapshot to accelerate startup time for the JVM. And with EclipseStore, we do pretty much the same with your application data to provide fully automated storage persistence for your Java applications. The functional principle is called system prevalence, is an architectural pattern, and this is not new. So a lot of companies do it already. So the banking companies, gaming companies do it because they have applications, so high frequency trading applications, and traditional databases are too slow. So what they did is, or what they are mostly doing is, they built a huge Java monolithic application, put a lot of memory in it, and then they can realize this high frequency, low latency trading applications because they are then able to process data in microseconds with pure Java. The problem here is they have to deal and to care for all database features like transaction safety, for schema migration, everything. So they have to implement this for their own. This is very effortful and expensive, and nobody wants to do it for business applications, for common business applications. But now with EclipseStore, we have a framework, and you can use it very easily. The functional principle is easy. So the system prevalence pattern says, yeah, keep your data in memory because memory is fast. Process data with your programming language and just create a snapshot of your system state to get persistence. That's it. Then your architecture will be simple, simple to design, simple to test, simple to deploy, no distributed applications. Sounds cool, but there are a lot of challenges because of, I cannot create a system, a snapshot of your whole entire system state. I cannot run a terabyte memory applications. This does not fit to our philosophy. So what is if the schema, if the class is changed? So there are a lot of challenges. And with EclipseStore, we have solved all of these issues. And you can use it now. So what is EclipseStore in a nutshell? EclipseStore adds persistence to the programming language, adds persistence to Java. And the vision initially was you get persistence for your Java objects and you don't have to care for it. The environment should care for persistence. And when we had this vision, so a lot of people said, come on, this is nonsense, cannot do this. But then Intel came up with persistent memory. So because we also thought about, actually, the infrastructure should care for persistence would be even easier. Intel came up with persistent memory, so you can get persistence for all of your objects in memory. However, this, I don't know what the problem is, so they sold the persistent memory business to SK Hynix. We have never heard much about persistence memory anymore. So, but we have a software solution, and EclipseStore is the solution for that. So, it is a persistence framework to replace Hibernate. It replaces not only Hibernate, also replaces database at all. You don't need a database anymore. You have your objects in memory, and it enables to synchronize your objects with the cloud seamlessly. It enables you to store any kind of Java object, any type, any complexity and any size of your object graph persistently into any data storage. So you can choose plain file storage. You can also choose S3, for instance, cloud blob stores. So this is recommended. And vice versa, it allows you to load data and restore, so load data from any storage and restore your object graph in memory fully automated. You don't have to care for that. No more classic selects. And you can load single subgraphs, so you don't have to load the whole system state. Framework is, of course, under EPL. You can use it for commercial purposes. It's an Eclipse project. So how does this work? Just a second. First of all, I want to show you a performance demo. And another hint for questions. So I forgot to If you have questions, please use Slido, and I will try to answer the questions at the end of this talk. So we have a performance demo here. This is a bookstore demo, like an online shop. So the code is on GitHub. You can check this out and play around. Here are two applications run in parallel. One is built with JPA. So one is built with, we use Hibernate. We use cache as a it's hot cache. So because the application is running, the cache is hot. And we use a PostgreSQL database, 250 gigabyte. The other application is built with EclipseStore. And here we can see also the query code. So we compare Spring Data queries with Java Streams API. And it shows plain streams code. So there's no magic. This is pure JVM performance. And the JVM will outperform SQL almost in any cases. So most queries are 10, 100x faster, sometimes 1000x faster than a comparable JPA query. So it seems you're not so excited, right? What is 1000x? So how does this work? Let's have a look inside the database. Here is our architecture again. So we replace Hibernate or data conversion, like JSON conversion, with EclipseStore. We keep data in memory. Our object graph becomes an in-memory database. So we don't need a local cache anymore. So we can skip a local cache. No more cache configuration. That's great. When we have a look inside the database, we can see we have storage, of course. We have a database management system. We have memory. So we need a lot of memory in database servers to get a powerful database, of course. And then sometimes we have some logic, business logic, stored procedures, stored functions. Who of you uses stored procedures, stored functions? Oh, not that much. It's because it's not covered by the JPA standard, right? So because we are Java developers, we want to store objects. We don't care for stored procedures, stored functions. So we don't use all of these database features. With EclipseStore, we go one step further. So we don't need all of these functional functions of a database, because the application logic can care for everything. So we care for validation. We can also care for concurrency. So don't be afraid of concurrency. Java provides everything we need. The only thing we really need is storage. That's it. So our architecture becomes really simple. I showed the performance demo already. So, but how does this work with distributed applications? So, of course, Java Streams API in one JVM is very fast. With distributed applications, it works equally. So we replace the JPA-based application cluster with EclipseStore nodes. And now we are able to replicate the object graph through hundreds, even thousands JVMs. And we are able to synchronize the JVMs by using replication. All right, so all of these nodes keep data in memory. So data are already in memory. They are replicated, which means actually we don't need a distributed cache anymore. So we can skip the distributed cache and save a lot of machines, a lot of memory, or we move the memory to our application nodes. So, and as I mentioned, we can store data on plain files or on a blob store, so we don't need a database cluster anymore. So we can skip the database cluster completely. The only thing we need is Java nodes, and a storage. Plain architecture, core Java. And you can also run this cluster as a service, so you can also build a .NET application or a Python application and query the EclipseStore cluster by using REST or GraphQL. This might be not that interesting for you guys. But this is possible, which means you can also run your microservices as serverless functions, so AWS Lambda, stateless, and query the EclipseStore cluster. This is by using REST. There is no client API to use, so it's just REST or GraphQL. There are some rules and challenges also with this approach. So because it's a paradigm shift in database programming, so we have to think a little bit different. On the left, you can see this is a traditional database server paradigm. The database runs on a remote machine. You query the database at the remote machine, and the application is separated from the database. With the EclipseStore paradigm, your database runs within your JVM process, within your application or in your service, in your microservice. And your queries are executed in the same JVM process as your business logic. And we only have storage on the other side. So and keep in mind, you cannot query storage. So all queries have really to be executed in your application node. This is the biggest difference. Some beginners are struggling with this functional principle, but yeah, that's the paradigm shift. And very important, we keep everything in memory, which means, do I need a terabyte memory? No, you don't. So if you have enough memory and you can load the whole database in the memory, please do it. This will be super fast and easy to set up and to run. You can do this, and it's recommended to do this because we save a lot of resources anyway, so we can invest in more memory. But if you don't have enough memory, if you want to run smaller nodes, you can have a terabyte data storage and only 4 GB memory. This will work also because we have lazy loading. The API is really simple. Using is, I would say, simpler than any database. It's because it's core Java. You can use POJOs. You can store all Java types. I mean, you can store everything that can be recreated. You cannot store a thread. But everything that can be recreated can be persisted. So there are no annotations, no superclass you have to use. There are no interfaces you have to use. So really, just POJOs. That's it. The only thing you need is a database instance. So this is very simple. You create a database instance and a root object. It's similar to a swing tree. Who is familiar with swing? Java swing? Okay, the older ones, so great. So it's similar to a swing tree. Everything that is reachable from this root object can be persisted. Very easy. So using is easy. This is just a dependency. You can download EclipseStore via Maven. Then you need this root instance, and that's it. And then you can add objects to your root. You can build up and design your object model completely freely. There are no requirements in terms of the design of your object model. There are no rules like relational databases have. So design whatever you like. It can be persisted. But keep in mind, don't design nonsense, right? So you can design an object graph that is difficult to search. Then your search will be slow, of course. So you have to rethink what you're really want to query later on, but there are no specific design rules. Okay, let's run an application. So here is your memory. Then we create a root object and a database, which means this is a storage. This is a file. It's just a file on your storage. You can use all storage targets, mounted volumes, SSD, blob store, even a database, because databases can store binaries, right? I don't want to confuse you. It's possible. Mostly it makes no sense. Just use a blob store. It's fully managed. Okay, then let's create some objects. This is also very easy, and we add some objects to our root object, and then you only have to call one method. This is a store method. That's it. Only one method. You have fully control what you want to store. So we add an object. We call a store method, and there is only one rule. You always have to call the store method at the owner object. So if you add an object to a collection, you have to, and then you have to store the collection. The great thing is, EclipseStore not stores the whole collection. It only stores the changes. Only the delta is really persisted on disk. So, and then creates a new file in the storage. So let's add some further objects. We store it, and we get another binary in a storage. For creating the binaries, we use the Eclipse serializer. The format is open, and it's built for dealing with high complex object structure with circular references. So it was not possible to use the Java serialization for that. So, and so on. So we create some more objects and store it. Each store is transaction safe. This is an all or nothing operation. And we store data always appended to your file storage. Each store is a new file, and the EclipseStore storage manager will reorganize your storage behind the scenes like magic, so don't have to care for that, and optimizes your storage all the time within a thread. All right, so we produce more and more binaries in a storage, and we always store the state. This is very important, and this is the difference to what event sourcing does. We don't store the events, we store the state. All right. Okay, let's change some objects. If you have some objects in the object graph, so we change an object, change some values, then we store the changed object. What happens? It creates a new binary, because we never overwrite data like the relational databases do. We always store changes, new objects appended to the file storage. So we create more and more data in the storage. So when you start an application, how does this work? We start an application, and then the engine loads the whole object graph, but only the representation of the object graph, only the object IDs are loaded into the memory. Then we have the representation of the whole graph, even if you have billions of nodes. And then you only have to call a get method. That's it. There are no classic selects, just call get methods. And if the object is already in memory, you get the object from the JVM. If the object is not in memory, the engine will load the object reference and merge the object reference directly into your object graph. So you don't have to deal with object copies. So let's load some objects. We call some get methods, and the engine loads the objects. This is very easy with lazy loading. This is just a wrapper class, so you are a developer. You can define your classes as eager or lazy. If you do nothing, it's automatically eager, and the engine will load data. Not only ID, also data are loaded. If you define your classes as lazy, only the object ID will load it, and the object reference will only be loaded when you call the get method to get the object. That's the functional principle. And it's the same with removing objects. So if you remove an object from the object graph, if the object is not longer reachable, the garbage collector will remove the object from the memory, and if you call a store method, then also the object will be removed from the file storage. So memory management is fully managed by the JVM. You don't have to care for memory management, but you have fully control of your lazy references. So if you want to save memory, then you can also clear your lazy references from the memory. You can define timeouts, so you have full control, but you can also let the JVM do the job. Queries, as I mentioned, queries are simple because we use Java Streams API, so for searching object graphs. It's type safe, it's super fast. We talk about microseconds. What is if my classes change? We have a solution for that also. It's called legacy type mapping. This is a very simple and convenient feature. So let's assume we load an object reference, then the engine compares your object with your class. If your class has changed, so you add some fields, you remove fields or rename fields, then we have a heuristic that can solve this conflict automatically, even if you change some primitive types. If for more complex cases, you can define a legacy type mapping. And then you store the object again, and then we get a new object persisted in a file storage, and then we have two versions of our object in the storage, the old version and the new version. And then we have so this is what now happens. So one object is now legacy, and we get a new object in the storage, which means the storage will grow more and more. And to clean up the storage, we have a kind of like garbage collector for the file storage. So here we can see we have, so the red ones are the legacy objects. And now we have a kind of like garbage collector for the file storage, and this garbage collector removes the older objects from your storage. You can configure that because, yeah, you can really decide when the garbage collector should work and how it should work. So this is the functional principle. We have 6 minutes left. So what's next? So we work on a EclipseStore cluster. It's actually available already. It's we work on the SaaS model, and it's available for on-prem. Software as a service is very easy to configure. You don't have to deal with Kubernetes, so you can set up and run a cluster with only some mouse clicks. We're working on this might be a little bit confusing, MicroStream memory grid. So this is a kind of like dynamic collection that you can browse through even hundreds of millions of records dynamically, so you don't have to care, you don't have to load all these objects into the memory. We add a new index API that allows you to create indexes similar to what databases do, but we believe a little bit faster. And also we work on combining EclipseStore persistence with the new Java Vector API and JVector to build high performance and really powerful machine learning applications in Java. So if this is interesting for you guys, check this out. So EclipseStore should be should be available as a final release soon. Yesterday, we were at EclipseCon, and hopefully they will do the legal checks, and then next week we will have the final release. It's bulletproof, so companies like Allianz, Fraport use this in production already for years. Now the framework is available as an Eclipse project, and you can build really fast applications, database applications in Java. All right, there are some questions. So I try to answer some questions here. There's another thing, not only questions. Please support our open source project. So if you have a statement now, you want to say, this is great stuff, then I tell you, I will convince our investors to invest more money, and then we will invest next year $10 million into this project. So if you guys have some statement, you want to tell us, that's great stuff, please raise your hand, get the mic, and then you get the t-shirt outside. Don't be shy. Support us, please. Okay, I answer some questions first. What are the challenges? So challenges, of course, there are pros and cons with all technologies. It's built for the JVM. It's not built for C# and not available in Python. There are no SQL support, so you cannot just query the database from outside. You cannot let third-party applications get access to your data storage. That's not possible, so it's built for Java developers. So you have to create interfaces to let third-party applications access to your data storage, to your database. You might say, okay, this is actually the right way. Yeah, but with SQL databases, this is possible to let third-party applications access to the database beside your application. Sometimes we have problems with consistency, but this is possible, and this is not possible with EclipseStore. So challenges are you have to rethink database programming. There is no database server. It's a completely different paradigm, and you have to think more object-oriented. Don't think relational. So forget everything you have ever heard of a database server. Do it like a Java developer. Does the performance demo include fetching data from clouds? No. In this performance demo, we only show how fast Java Streams is in comparison to fetch data from a hot EH cache. So Streams is even faster than fetching data from a hot EH cache. That's incredible. So if we fetch data from disk or from a database, sometimes this is even slower. So we wanted to compare the fastest cases, and the fastest cases with JPA is reading data from a hot cache, right? How do you deal with concurrency? This might be an issue. Who of you is afraid of concurrency programming in Java? No one, because we are all experts. Yeah, it might be challenging. So this is what probably a database does. In a microservice environment, we don't have these technical transactions anymore, actually. But I know, so these are concerns. In Java, we have multiple options to deal with concurrency, and you can do whatever Java provides for dealing with, for handling concurrency. And you have to do that. So you have to care for what you're doing. That's really true. But the result is you get a plain architecture, extremely fast application, and you save 99% data storage costs in the cloud. Just for a little bit concurrency programming in Java. Yeah, but this can be challenging for somebody. How data is synchronized about latency. So how do we synchronize the nodes? So we have the cluster concept of replication is, so the strategy is eventual consistency. We delegate all stores via event streaming. So through event streaming to all of the reading nodes. The latencies, so it depends on the infrastructure. So if you run this in AWS, so this is the common latencies we have in an AWS network. We cannot eliminate physics, of course. But we talk about millisecond, mostly milliseconds. So this will, of course, be much slower than running an application, running EclipseStore embedded within only one JVM, of course. So if you distribute the application, then it will be slower, but we cannot eliminate physics. What is your business model? So I mentioned the cluster. So the framework is completely open source, EPL, and the cluster solution is closed source, and we provide it for on-premise and as a fully managed service that you just can set up clusters easy and simple and fast. And on top of the infrastructure prices, we add a fee between 20 to 30%. So this is the business model. But keep in mind, this framework is so powerful that you can create great applications even with the open source framework. Garbage collector cycles, you mean the JVM garbage collector, so you don't have to care for garbage collection. So this is everything managed by the JVM. And so the JVM vendors are responsible for this stuff. But Azul, for instance, they say they are able to even run terabyte of or handle terabyte of memory without garbage collector issues. Check this out. We have measured OpenJ9 is very performant and works great with MicroStream or EclipseStore. And the later Java versions are much faster and more efficient than the older Java versions. So your performance depends really on the JVM, the Java version you use. That's great. So the later Java JVM versions are more powerful, and with virtual threads, this will also influence the performance of your application. So that's great. Java ecosystem provides us a lot of benefits. So there are a lot of more questions. I will answer all of these questions at our booth. Please visit our booth. You can join the raffle, and tomorrow probably we have new EclipseStore shirts. And if one of you now want to give a statement, please raise your hand, then you will get a t-shirt. Come on, please. For $10 million, invest into EclipseStore. No one. This is boring stuff. No, we don't use it. You can say, this is great stuff. This will change the whole database world, and I will probably buy a MicroStream cluster for $10 million. Then you get a Porsche on top of that.
Okay, so do I start? Am I being filmed? So this is great stuff. I actually can imagine that it will revolutionize persistence technology in Java as we know it. And yeah, I will totally buy it for $10 million.
Awesome, nice. Who wanna? Yeah, thanks, applause. Yeah. So who wanna invest 20 million? Yeah, we can say, yeah, we have challenges with Hibernate, and it's really slow, and this is more performant. But you can do this at our booth. So next speaker will wait, actually. So thank you very much for joining. It was a pleasure. See you, and have a great day at GeeCON. Thanks.